you asked a question. You want to talk a little bit about chain rule.
Yeah.
Um, do you have a function that we could do for an example?
Yeah, I wanted to do one of the functions from the problems that were the practices.
Oh, good.
So the function is e to the 5x,
Okay.
and then
So,
parentheses, there's more parentheses, x squared plus 7 to the x, close parenthesis, and then that's it.
okay, like that?
Yeah.
Okay. So a lot going on in this problem, right? So
Mhm.
just describe for me, like, what's some of the stuff you see in terms of what functions do we have floating around?
So we have e to the 5x, which is the outermost function. I believe that's how he said it in the video that we watched.
Mm-hmm.
He focused on that first, and then there's the second one that's in the parentheses.
Okay. So we've got the second one in the parentheses, and then there's actually, so there's two of them that are added together in there.
Yeah.
And there's even kind of one more function hidden
What would that
away.
be?
That's this kind of 5 times x.
Okay, so that's its own thing.
Right.
Okay.
So these two are put together. This is not composition, right? This is multiplied.
Mm-hmm.
Okay, so that's for that we need product rule. But this part, like having the 5x in the exponent, that's going to take chain rule because it's like we're putting 5x into the function e to the x.
Okay.
Okay, so if we want to do the derivative of this function, kind of like the last thing done is multiplying the two functions together, right? So this kind of this thing and this thing, like if we wanted to figure it out, we'd have to figure out 5. If we put in a number 2, right? We'd have to do 5 times 2 to get 10. To do e to the 10, we'd have to do 2 squared. We'd have to do 7 squared. We'd have to add the x squared and the 7 to the 2, and then we'd have to multiply those things together. So
Okay.
sometimes I think about it like the kind of like that's that last thing we do is often kind of the first thing we deal with in the derivative. So the first thing we deal with is going to be kind of product rule, right? And the product rule is like the derivative of the one times the other plus the first times the derivative of the second. Okay.
Okay.
And then the chain rule is going to come up because we want to do, um, so what's going to go in here is this kind of derivative of that e to the 5x. And to take the derivative of that is when we need the chain rule. So, so it's like, so why the chain rule happens here. So if we put that 5x into the u function, that's how we get stuff like this. Okay.
Okay, so you switch, you plug in. Do you switch it around from the original? How do you do that? Because I know the derivative's different than what the
Right.
original
So
is.
So if we do the derivative of this thing, we get the derivative of that outside function, like you were calling it, still with 5x in it, and then times the derivative of the 5x. So do you remember off the top of your head what's the derivative of the e to the x?
No. Is it the natural log?
The derivative of any like number raised to a power does involve natural log,
Okay.
but it's like the natural log of the base. So in this, and so that's going to come up with that 7 to the x as well. But in this case,
Okay.
the natural log of e is 1. So the
So every
derivative,
time you're putting x in the exponent or in the squared area, it's going to be the natural log of it.
it's going to be, so what it turns out is that the derivative of these exponentials is the same thing times the log of the base.
Okay.
Right? So you wind up getting just this kind of constant multiplying the original function, which is
So for the 7 to the x, it would be 7 to the x log of 7.
exactly, yeah.
Okay.
So when we get to that part, that's what it's going to be. So in this case, the derivative of e to the x is e to the x. So the derivative of e to the 5x is going to be the e to the 5x. But then we have to multiply it times the derivative of 5x. So what's the derivative of 5x?
I'm not sure. So are you not using that e to the x times the natural log of e, or would that be there?
We did that. That's why the derivative here, right? That's kind of what we put here, right? So the
Okay.
derivative of e to the x is just e to the x. So we put the 5x in that. We could multiply by the log of e, but that's the part that's 1.
Okay.
But now we've got to multiply by the derivative of the thing we put inside.
Okay. So how would you make 5x into a derivative? I think that's my biggest problem is realizing how to turn them into
The derivatives, yeah.
yeah.
So, and it's a lot of different pieces, kind of moving pieces to keep together when we're going through this.
Mhm.
So the derivative, 5x is a polynomial, like a really simple polynomial. So
Mhm.
that's where we use the power rule. And if you think about it, like if the function was y equal to 5x, that's just a line.
Yeah.
And what's the slope of that line?
0.
No, it's not flat, right? That would be slope 0. Like if y was equal to 5, right, that's a flat line. So the derivative is 0.
Mhm.
Y equals 5x, the slope of that is the 5.
Oh, so the 5 over 1.
Right.
You go 5 over 1. Okay.
So the derivative of 5x is actually just 5.
Okay.
And from applying the chain rule, that's this second part. That's the derivative of the inside. The inside was 5x. Okay. So all of that was just, we need kind of 4 pieces, and that was the first piece of the 4 pieces.
Okay.
But because that was the chain rule part, that's the most complicated part of the 4 pieces.
Mhm.
Okay. So the product rule is the derivative of the one part times the other part.
So it would be times what's in the parentheses.
Exactly.
Okay.
Okay. And then the first part times the derivative of the second part.
Okay. So then you have to take the derivative in the
Right.
parentheses.
So what's the derivative of x squared?
So wouldn't it be 2x?
Exactly.
Okay.
And the derivative of two things added together is just adding together the derivatives. Right? So that's why we're not having to do anything fancy. These two things, x squared and 7 to the x, are just added together. So we're going to get to just add together the derivatives.
Okay. And then for the 7 to the x, it would just be the natural log of 7 times the 7 to the x.
Exactly.
Okay.
Didn't give myself quite enough space there. Okay. And so now we know all this. For my sake, you do not have to simplify this stuff.
Okay.
And in fact, when we're doing work with the derivatives, a lot of times we could see, like, if there was something we wanted to factor out, like that e to the 5x or something, we can see it better when it's written kind of all out.
Yeah. Okay. That makes a lot more sense now.
Okay.
So for when you take the derivative, I'm still a little confused on this, of something, you're looking at its slope, essentially,
Mm-hmm.
at that. Okay. So then for the x equal, or the x squared, if you put it in the y equals x squared, the slope for that would be 2.
Well,
2x.
the slope for that is 2x. So it turns out that the slope at 0 is 0. The
Okay.
slope at 1 is 2. The slope out at 5 is going to be 10.
Oh, okay, yeah, because you just plug it in for the x. I
Right.
see.
And that fits parabolas, right? Because parabolas are level at the vertex, and then
Hmm.
they start getting steeper and steeper slope the farther out you go.
Okay, that makes a lot more sense.
Okay, really good question. So can we do an example where you try to talk me through it?
I can try.
Okay. So let me do, so if this is our function, what's the derivative?
So we started out the same as last time, right? Where you write f, the derivative of x equals, and then you separate it into 2 since there's addition. Or would it be 3 this time since there's 3 separate parts in the parentheses?
Well, that thinking about the structure is like exactly what we will kind of want to do.
Okay.
So tell me kind of the parts you see when you're looking at this function.
So there is the cosine, that's one part of it.
Okay.
And then inside the parentheses, there's 3 separate parts. So you'd be wanting to multiply the cosine by the 3 different parts separately and adding them all together.
Okay. And so are these, is the x squared plus x plus 1, is it multiplied times the cosine, or is it like this function composition put inside the cosine?
Um, I'm not sure because for the last one we had the parentheses and the e to the 5x and then we multiplied
Right.
and then add. But this one doesn't have that exponent, so would that make it different?
Well, what makes it different is like, so this is different um, than this, right? So these two things are not the same
Oh,
because,
okay, because in that x, so they're okay. I see.
so can you put in your own words kind of what makes the difference?
So in the one you typed out, the cosine of x is multiplied by those, but this one, the stuff in the parentheses is in the cosine still. It's of the cosine.
Oh, that's put really well. Okay. So that's what makes this chain rule situation instead of a product rule.
Okay. So then the chain rule, they would all be added together.
So the chain rule is like this. If we have one function of another function,
Mhm.
we take the derivative of the outside function, which in this case, kind of what's the function that we're putting another function into?
Um, the stuff in the parentheses.
Right. So the cosine, we're putting that stuff into. So we're going to want the derivative of cosine with that same stuff in the parentheses. And then we multiply by the derivative of the stuff in the parentheses.
Okay. So when you set that up, um, I'm trying to think because I'm looking at the notes that I took. So do you want to set it up with the way you wrote it out to the right of the equal sign in red up there? So it's going to be, okay, derivative of the cosine, same inside times the derivative. Okay, so you don't want to rewrite the regular cosine like we did last time. It would just be the one derivative times both.
Right? Because this is not what we're taking the derivative of. Right? We were saying that what we've got is something different. Okay, and then here's where either we remember or we look up somewhere what the derivative of cosine is.
Would it be sine? I'm not sure, but
So turns out the derivative of sine is cosine, but then the derivative of cosine is minus sine.
negative sine.
And how I remember it is, right, cosine starts at 1, and then it's going down.
Mm-hmm.
So to get a negative slope there, right, sine is positive in the same place. So that's why we need the minus sign, is to make
Okay.
it be like the slope.
Oh yeah, I remember. I think we did an exercise on that earlier on.
Okay, so the derivative of cosine is minus sine. And then what do we put in the parentheses here?
So the same thing, x squared plus x plus 1.
And now we multiply. And what do we multiply by?
So the derivative of x squared would be 2x, like we said above, of x. I'm trying to think. So if you take y equals x, that slope, I can't think of that slope.
Turns out it's just 1, right?
Just 1? Okay.
Because x is the same as 1x, but lazy mathematicians, we don't write down the 1.
Okay, that's what I was thinking. Plus, and then plus 1, would that be a slope of 0?
Exactly.
And then you said you don't want us to factor that out, so would it be done after that?
Yeah, so you can be done. And right, or I mean, we don't have to write down the plus 0, but but yeah, the other reason I don't mind when it's kind of written out without the simplifying is that it shows much more of kind of what you were thinking.
Okay, perfect. Yeah, that makes a lot more sense going over and doing it a few times.
Okay. Thank you for letting me record that.
Yeah, thank you for helping me out.